Today we will talk about scatterplots and the correlations that they show between the two variables that are being displayed. Two or more things can have a relationship which is called a correlation, sometimes referred to as association. These correlations can visually be represented in scatterplots. There are 3 scatterplots shown below, and they represent the 3 types of correlations. The first graph shows a positive correlation. What that means, if you visually look at the graph, it looks like the graph is moving up from left to right. Okay? A positive correlation can also be described like this. You've got the x values and you've got the y values, right? So as the x values increase, the y values also increase. Or you can view it like this. As the x values decrease, the y values also decrease. Let's look at the graph the same way. I've got some points down here, and I've got some points up here. The points down at the bottom, they both go to low x and y values. The points more near the upper right part of the graph are both associated with higher x and y values. The middle graph is an example of a scatterplot that shows a negative correlation. It looks like the graph goes down from left to right. So one way we can imagine this, or we can look at this as the x values increase, the y values decrease. Or, similarly, as the x values decrease, the y values increase. So if I'm looking at my graph, if we pick a couple points on kind of like each end, the point on the left is associated with a low x value but a higher y value. The point on the bottom right is associated with a high x value but a low y value. So with negative correlations, as one variable increases, the other variable decreases. They move against each other in different directions. Compared to the positive correlation on the graph with the green dots, as one variable increases, so does the other. And the opposite is also true. As one variable decreases, so does the other. So in a positive correlation, they move in the same direction. Negative correlation, they move against each other in different directions. Positive, they move in the same direction. In the last graph, this is an example of a scatterplot that doesn't appear to have any correlation. So we just say it has no correlation. There's no pattern being seen. There's no relationship between the x and the y. So sometimes when we have a scatterplot, sometimes it helps if we draw in trend lines or lines of best fit to help us to use the data to do other things with. So a trend line, which we'll look at in just a minute, it's a line on a scatterplot that is drawn close to the data points. This can be drawn by you and me. It's just an estimate, but it helps us to make predictions. The line of best fit, this is the most accurate trend line, and this is determined by a calculator. So this is what we'll be doing next week, so you'll need to definitely have your calculator charged. So let's take a look at a few examples of some scatterplots. Here are 2 scatterplots. The left is showing a positive correlation, and the right is showing a negative correlation. There also is that trend line, or line of best fit, drawn through most of the dots. Now, if this was drawn by a calculator or a computer, we would call it the line of best fit because it's the most accurate. Otherwise, we can draw this by hand. But these lines can be used to help us make predictions. So, for example, and this might not be the best example, but if I was to extend my trend line beyond the data, I might be able to predict that there might be some points up here, kind of off my graph a little bit, and then I could follow those points down to the X and Y axes and make some predictions about some future data. Let's take a look at these though and what they represent. So the positive correlation on the left, here's an example. The X-axis has SAT scores and the Y-axis has high school GPA. So this is saying that the higher your GPA, the higher your SAT score, the higher your GPA. GPA is determined by your grades. It's also showing the opposite of this. The lower your SAT score, usually the lower your high school GPA. So these are examples of points or data that is moving in the same direction. So down here, we've got low SAT scores matched with low GPA. Up here, we've got high SAT scores matched with high GPA. Now let's look at the negative correlation on the right. This one is showing on the x-axis cholesterol consumption and on the y-axis life expectancy. So this is showing the two things that are being compared as moving against each other. So for example, when you have high cholesterol, your life expectancy is very low. That means you're not going to live very long. It also says when you have low cholesterol, your life expectancy is very high, which means the lower your cholesterol, the higher you live, or the longer you live. So this is an example of where the X and the Y, they move in different directions. Causation can be very hard to prove. Causation is when a change in one of the quantities is the cause, the direct cause of the change in the other quantity. Sometimes you can have a positive correlation or a negative correlation and it looks like they are completely correlated, but it doesn't necessarily mean that one thing caused the other. It could just be by chance that they happen to move either in the same direction or in different directions. So, write this down. A positive or negative correlation does not imply causation. So just because two quantities appear to have a positive or negative correlation does not mean that one of the quantities caused the other one. Here's an excellent example. There is a positive correlation between ice cream sales and murder rate, which means if I could find a graph to show you, the more ice cream sales we had, the more murders there were. Well, this is an example of a positive correlation that does not have causation. Selling ice cream does not cause people to murder each other, and murdering each other does not cause people to buy more ice cream. So write that down as an example of a correlation that does not imply causation. So if you had a STAR test question about causation and it asks, does this have correlation and causation? It would be absolutely 100% obvious that there would be causation. So an example of causation might be a positive correlation between the amount of rain and the height of the lake. The more it rains, the higher the level of the lake is with water. So that would be a direct causation. Okay, so believe it or not, that's the end of these notes. Come to class, we'll try some examples, and then you'll be on your way. See you soon.